Hi, this is Doug Hoover from the SAP Platform and Technologies Virtual Pre-Sales team. What I'm going to be talking about today is a technical overview of a new feature in HANA2 SP4 called Native Storage Extensions. So let's jump right into it. So what Native Storage Extensions allows you to do is specify certain data as page loadable. So what does page loadable mean? So by default, HANA loads all of our columnar tables in memory. So they're in memory at rest. And when HANA needs to unload or reload any of this data, it loads it by column or by a partition of a column. So that's what we call column loadable data. So what NSE allows us to do is mark certain data in HANA to be page loadable. And that means two things. One, the data at rest is not going to be in memory, but the data at rest will be on disk. And then HANA will page in that data as it's needed for query processing. So it can actually load the particular columns needed for a query and just the particular pages of those particular columns. This will significantly reduce the memory footprint for any of the data that we mark as page loadable. Now this data at rest will be on disk. So we will get a little bit of a performance impact. So this will be a little bit slower than our in-memory data. But remember, again, this is still a columnar database. So this is going to be much more efficient and much faster than a traditional row-based database. And this data is easily altered. So with a simple alter table command, we can move data from page loadable to column loadable or column loadable back to page loadable. Another significant feature in the NSE is the fact that we are reserving data for this NSE feature, or reserving memory for this NSE data. So two key benefits of that are, one, we end up with very predictable performance since we're not competing with the hot in-memory data for any memory. Second key feature of this is that memory is reserved, not allocated. So what this means is that if we're not accessing any warm data at a particular point in time, all of that memory that we have reserved for the NSE data is available as working area for our hot data. But the most exciting feature of this new NSE is what we can actually mark as page loadable. So we can basically mark an entire table as page loadable. So we can now load huge amounts of data into HANA that maybe would not have fit before. So you can think of things like remote data that you might be accessing today that's in other databases, and maybe you're not getting the performance or the reliability that you need. We can now replicate that data into HANA, as well as load other demographics data or any other data sets that you've wanted to load into HANA and be able to analyze with your HANA data at very fast, but maybe not sub-second type performance. The other thing we can do is we can mark a partition as page loadable. So this is more the traditional hot, warm type scenario that people think of. So you could keep maybe 2 years worth of data in hot memory, and then the next 8 years worth of data if you're keeping 10 years in total as warm data. So you can keep those partitions that are containing that older data as governed as page loadable data. But then one of the most exciting features is we can also mark a column as page loadable. And this is exciting because if you think of the way that our applications like S4 and BW4 and other customer applications that have migrated to our columnar database have started taking advantage of the whole columnar structure by creating very consolidated schemas, very simple, very consolidated schemas that are performing amazingly fast. But as part of this consolidation, our table sizes have grown to maybe 200, 300, even 400 or more columns in size. Well, all of those columns may not be accessed as often as the other columns. So say in a 200 or 300 column table, you only have 100 columns that are most frequently accessed. You can now mark those other columns as page loadable. So this not only gives us the normal horizontal partitioning that we get out of databases normally, but this is starting to give us some vertical partitioning of the data as well. So now we can actually store some of the columns in our column loadable formats and our other columns as page loadable formats. And on the right side here is the actual SQL that you can run to do that. So this first example, we're creating a table called T with two columns, C1 and C2. And in this first example, C1 is using the default or column loadable. And in column C2, I'm sorry. In this example, we're actually marking the entire table T as page loadable. So this is putting that entire table at rest on disk, and then we'll access the two columns as needed. In the second example here is our partitioning example. So we're taking that same table and we're breaking it into two partitions, and we're marking that first partition as page loadable, and we're marking that second partition as column loadable. So the first partition will be stored in the warm or on disk store, and the second partition will be stored in the columnar or hot store. And in this third example is where we're actually moving column 2 to page loadable. So again, column 1, C1, has nothing after it, so it's using the default column loadable, and C2 is then marked as page loadable. And then we can also do each of these commands in an alter table as well. So if you've already have existing tables and you want to move the entire table or move a partition of that table or move a certain set of columns in that table and mark those as page loadable, you can do that with an alter table command as well. We've also extended all of our tooling to support this. So our HANA Cockpit tool allows you to modify the amount of memory reserved for NSE. By default, that's 10%, but we'll show a couple examples later on how we can shrink or grow that number. Cockpit also allows you to configure the particular columns, tables, or partitions that you want to mark as page loadable. It lets you monitor the usage. We even have a recommendation engine built into it that will give you some recommendations on what pieces of data should be moved to page loadable, or what pieces of data can be moved from page loadable back to column loadable. We also have Data Lifecycle Manager modified for this, so if you want to go ahead and define particular business rules around what data should be page loadable or column loadable, and then execute those on a particular schedule, that can be done with the Data Lifecycle Manager. And then we've also expanded our visual query plans in Web IDE so that you can see the impact of this on any particular report. So let's talk about the sizing rules and run through a couple examples to help show those. So the 3 rules you have to remember are pretty straightforward. The amount of data that will allow to be put in the NSE or page loadable format is a 1-to-4 ratio to your hot data. So in the example we have on the right, we're talking about a 2 terabyte HANA system. And then again in HANA, we split the memory in half, using half of that memory for the working area and half of that memory for the database. So that gives us a terabyte of hot data. So the maximum amount we would allow in the warm store for that database is 4 terabytes, or a 1-to-4 ratio. Also in this first release, we're limiting the total size of the warm store to 10 terabytes. So if you have, say, a 5 terabyte HANA system that has 2.5 terabytes for the hot data, we will allow that to have a 10 terabyte warm store. But if you have a 6 or 7 or even bigger HANA system, we're still going to limit the warm store to 10 terabytes for this first release. The other rule to remember is a 1-to-8 ratio, and that's the amount of memory you need to reserve as compared to the amount of warm data that you have. So let's run through a couple examples of how to use this. So again, if we're starting with a 2 terabyte HANA system that has a 1 terabyte database in it, we can, in the first example, simply add a 0.5 terabyte to the system, right? So buy an additional 0.5 terabyte of memory for that system and buy an additional 0.5 terabyte of HANA for that system, and then reserve that new 0.5 terabyte of memory for NSE to use. So again, we're reserving that, but we'll only use it as you're accessing warm data. So if we reserve 512 gigabytes or 0.5 terabyte of memory for the NSE, that'll give us a 1-to-8 or a 4 terabyte warm store at the max. So in this example, by just adding a 0.5 terabyte to the system, we were able to grow our 1 terabyte HANA database to a 5 terabyte HANA database. 4 terabytes of that being warm or on disk, and then 1 terabyte of that being our hot in memory. Another example is we can again take that same 2 terabyte system that has a 1 terabyte database, and then we can just take 400 gigabytes of memory for that system and reserve that for NSE. So what that would give us is, again, using the 1-to-8 rule, it would give us about a 3.2 terabyte warm store at the maximum. But now that we've taken 400 gigabytes of memory away from our hot store, that leaves us with 1.6 gig of memory that we can then split in half and use 800 gigabytes for our working area and 800 gigabytes for our hot store. So in this example, we've actually shrunk our hot store from 1 terabyte to 800 gigabytes, but we've gained 3.2 terabytes in our warm store. So our total database size has grown from a 1 terabyte database to a 4 terabyte database. Okay, so as a summary here, the key benefits of this NSE feature is the fact that we're just allowing you to add huge amounts of data to HANA with little or no additional cost. And we're giving you the ability to not only put complete data sets on disk, but also to do vertical and horizontal partitioning of the column or database tables across memory and disk. So this basically extends the HANA database to support this pageable columnar database tables with very efficient and very quick access. And we can store, again, entire tables, partitions of tables, or specific columns in the table. So I've given you 3 links here for some more information. This first link is connecting to our HANA Administrator Guide, which has a section that goes into much more detail than I was able to cover in this brief overview. And then we also have some information here on some of the administration and monitoring and that recommendations engine that we had. So I want to say thank you, and I hope you found this to be interesting as well as informative, and I look forward to speaking to you again.